Good evening, everyone. Thanks again for making it. Let's jump in. Looks like we have a pretty full house, and we're ready to get started. I want to thank everyone again for everyone who's in attendance to learn about the Metrowest Solar and Clean Heat Challenge. My name is Sean Luz, and I'm the Sustainability Coordinator for the City of Framingham. I'm joined here tonight by some colleagues from the towns of Ashland, Holliston, Natick, as well as some clean energy installers to talk about this new program and our goal to provide you with a competitive option to install solar panels as well as heat pump technologies for your home or small business. We've got a jam-packed agenda tonight, and we want to make sure we get through all the most important information as well as your questions, some of which you've sent before the meeting. Thank you for that, by the way. We'll start with a quick overview of the program, as well as some introductions of the team. And then we'll also get into some great presentations from our selected installers about the clean energy technologies that they're offering through the program. A quick note, as I mentioned before, if you do have any questions, don't hesitate to send them in the chat. As we go through each technology, we're going to take a brief pause to answer a few questions. And then towards the end of the presentation, we'll have a longer Q&A session. So first, some quick introductions of the municipal team supporting the program. My name's Sean, of course. I'm the Sustainability Coordinator for the City of Framingham. I'm joined by Frank in Ashland. Frank, if you want to just introduce yourself.
Thanks, Sean. My name is Frank Nicashian. I'm the Sustainability Coordinator with the town of Ashland, and I want to thank everyone for attending this awesome presentation. I'm looking forward to hearing what our great installers have to say.
Awesome. Thanks, Frank. Joined by Matt from Holliston.
Good evening, folks. I'm Matt Zedek, Sustainability Coordinator for the town of Holliston. I'm really thankful you're here to learn more from our selected installers.
Awesome. Thanks, Matt. And Jillian from Natick.
Hi, everyone. Jillian Wilson-Martin, Sustainability Director from the town of Natick. Hi, especially to all my Natick friends. Thanks for joining tonight, and I'm excited to share this technology and this program with you.
Thanks, guys. So, moving on to the program. So to get us started, I just want to talk a little bit about why our 4 communities have worked together to develop this program. So as many of you may have seen in planning efforts across our communities, we're seeing rising temperatures and intensifying weather in the Metro West. We can already see and feel the impacts of climate change in our communities. And it's clear that reducing our greenhouse gas emissions will play a vital role in protecting our environment and our communities moving forward. In fact, our state has adopted a very aggressive goal to become net zero by 2050, a goal that many communities such as ours are working to align ourselves with. As you can see in this chart, residential activities, including how we heat, cool, and power our homes, represent the primary source of local greenhouse gas emissions, as shown for Natick in this example. So generally speaking, how can we reduce our emissions and make progress to becoming net zero communities? As you may have guessed, an important way to do this is to change how we heat, cool, and power our homes and businesses. So with technologies like solar panels, which can convert sunlight into electricity, as well as air source and ground source heat pumps, which provide extremely efficient ways to heat and cool our homes and businesses across and throughout the seasons. These are our major clean energy tools that we can rely on. But of course, making that transition to these technologies can be overwhelming, and there can be a lot to learn and consider for a home or business owner interested in taking the next steps, whether it's to install a solar energy system or install an air or ground source heat pump. Our goal with this program is to address some of these major challenges. So for one, the communities, we see this as more than just an isolated issue that any of us are facing. We wanted to take a regional approach to promoting clean energy technologies. Also, as a community-based initiative, we wanted to leverage these resources that we have through the program to engage and educate members of our communities about how clean energy can benefit them, not only in providing cost savings, but also making their home more comfortable. To provide the most helpful program, we also wanted to build off of successful practices established by the state. We're thinking of programs like the Mass Clean Energy Center's Solarize program, which you may be familiar with. And of course, we also want to be able to empower you with competitively selected options for clean energy technologies that include, discounted pricing for solar and heat pumps. So, oh, my apologies, I scrolled ahead too fast. We're happy to finally launch the program. And regarding this point, we're also excited about the possibility to offer program pricing that is cheaper than average costs. While recognizing that there are, of course, different types of systems, and each system, whether it's a solar energy system or a heat pump system, is different across a project. It could be a different type of system, different sizing, and different specifics. We looked at recent data from the Mass CEC and Department of Energy Resources, which also helps illustrate the potential savings that can be achieved through the program. So as you can see, base solar program pricing offered per watt is lower than the current Metrowest average, as well as Natick's 2015 Solarize program. So just kind of illustrating the savings that can be obtained if you were interested in pursuing solar through this program. Discounts extend to air source heat pumps. Shown here is the cost per ton for the Metrowest Solar and Clean Heat Challenge compared to the average for Middlesex County in 2019. Additionally, ground source heat pumps offered through the program also compare favorably to Massachusetts average costs, data that we got through the Mass CEC. So all this is to say that, while we welcome you to seek additional pricing, we believe that the program offers a competitive option to implement solar and heat pump projects. And before I hand it off to our first presenter, Ace Solar, just a couple really quick updates. So we want to make sure you take notice of the website for the program, which is metrowestcleanenergy.com. We encourage you to visit. There's a lot of great resources there, a lot of great information. And additionally, there's the opportunity for you to sign up for a no-cost clean energy assessment. And you can do that by clicking the sign up button right on the right-hand side there. Additionally, as I mentioned, the website has a lot of great information about upcoming events that we're working on together. Things like open houses, farmers markets. Each of them will give you a new opportunity to learn about these technologies and in some cases see the technologies in action. And with that, I'll hand it over to Casey Boldock from Ace Solar to begin their presentation on solar, of course, and then also about their offer through this program. So Casey, take it away.
Of course, right when I share my screen, it moves the unmute button. But thank you, Sean. Good evening, everyone. Thank you for having us. And I am Casey Bolduck. I'm the Director of Marketing with Ace Solar. We were honored to be selected for this program. And actually, just before I get started, let me start here. I think this is a great opportunity. We've participated, before I jump too far ahead, in several Solarize programs sponsored by the state, and it was really inspiring to see the local communities here coming together and taking the initiative to put something similar together on their own. And again, we're really honored to be taking part in this. Who we are, a little bit about us. We were founded in its current form in 2015 by our partner owners, two veterans who are also two brothers and their nephew, so family owned as well, local as well. We grew up in the Merrimack Valley area, and we're based right there in North Andover. And also we've been ranked the #1 solar installer for the last 4 years by Solar Power Magazine, something we're also quite proud of. Let's see. I'll turn it over to Colby for a little bit about how solar works. This is a quick intro.
Thank you, Casey. Yep. And again, I'm Colby with Ace Solar. So how does solar PV work? Solar panels, we know, convert sunlight into energy. So it's not heat related. It's just with light. And photons, which are the particles of light, will knock electrons free from atoms, and this creates electricity. But every solar system is also paired with an inverter, and the inverter is converting the direct current of energy into alternating current, and then that becomes usable energy for your home or business. And what we are offering for this program, we have heavily discounted pricing for both solar and batteries. And we really customize every project to your needs. For this program specifically, we have 2 different types of panels. And we can, if you go to the next slide, Casey. Again, it's very custom to what you need. So most people think of solar going on top of your roof. But if that doesn't work for you, maybe your roof's really old or it doesn't get enough sunlight, we can also do ground mount systems as well.
Yeah, absolutely. And I'll chime in there as well. I'd say, to Colby's point, it's a very customized approach. So kind of tough to put a number on the discount, but roughly in the ballpark of 20% savings compared to our standard offerings. So a really big opportunity to take advantage of that. And also bridging on that point, ground mount as well. I really personally always like to see the fun projects come together. So non-traditional things like carports or pergolas or things like that. We can also help out with that as well, working with other construction partners and contractors, for the structure side of things. And this is coming from experience too. I will say, I'm probably lowest on this list if I'm looking through right, but it's backed up by a lot of experience. Partner owners Bob and Mark are the 2 brothers, and Eric is their nephew. Also those are the 3 partner owners. Eric's been in solar for over 20 years, and him and Dale Myers in the top corner there have been. We always like to joke that Dale's been in solar since solar existed. So a lot of experience there, and again, backing up the whole team of that. Turn it over to Colby for a little bit about the incentives.
Yeah, so it really is a great time to go solar. There are a lot of financial benefits to it, and they can be limited. So for the federal ITC, you can claim up to 26% of the cost of your installation. But that is this year, and it does step down, I think, to 22% next year. So this year, if you were considering solar, you would be saving a lot of money doing it in time for that great program. And then Massachusetts has something called the SMART program. And this is a really incredible way to just even increase your savings even more with solar. And it can pay you for 10 years for the energy that you produce. And there are also great financing options. So we have low interest solar loans. So you can actually go solar for $0 down, and you can start saving right away.
Little cameo by the cat there, I think.
It's so embarrassing.
No, it's fine. But and touching on that as well, I know the SMART program mentioned 10 years for that incentive. For larger systems or in the commercial realm, those would be extended for 20 years, so even longer of an incentive for that.
And as far as our process, it's pretty easy. It can start with a simple conversation. If you don't like phone calls, you could always just send us an email. That's fine too. We will look at your house virtually. So we typically use Google Maps and other virtual things just to get a sense for the roof, and then we can start analyzing. And we'll also want an estimate for how much electricity you use so that we can customize the project to be exactly what you're looking for. And from there, then we can generate a proposal just so you get an idea. There's no obligation. We'll give you a proposal and you can see if it would work for you.
Thank you, Colby. And actually, just before I jump ahead, I saw just out of the corner of my eye a question about the loans. UMass 5 is a bank lender that has particularly a My Solar loan that they're offering. And that's a company we've worked with quite a bit for more recently anyways. Some good terms there. So just in the meantime, it's something you can look into, but we'll provide information on that as well. And as Colby mentioned, getting to that proposal, we can actually include that loan information along with the proposal, right? And again, as Colby mentioned, we're looking at it from a satellite view. A pretty good technology that can be pretty accurate with the measurements there. Of course, in the end, we are going to come out to the property and confirm those measurements to make sure that it all makes sense. But from here, we can get an idea of the cost of the system, obviously, what all the components that we would need, and then get a really, really good idea of how much energy we can generate. With your electric bill that we requested early on, we can give you a nice comparison of kind of what life was like before solar, and then what this solar array would do for you from a financial perspective. And that'll break down all the incentives, including those tax credits, an estimate of that, as well as the estimate of what you would see from the SMART program, in addition to any rebates or anything else that might be available. And another one, I can't help but see the questions out of the corner of my eye. So yeah, I'll talk a little bit more about panels and equipment during a future broadcast webinar. But we do use both string inverters and micro inverters, or either, I should say. So both options available. And then jumping back a little bit, the timeline for things. So as Colby mentioned, we'll start with the proposal. Typically within a week, we can turn that around and then have a conversation, obviously customizing as need be. From there, if you're interested, we sign a contract, small deposit, or in the case of a loan, just kind of validation that the loan's moving forward. From there, we would start with that site visit to confirm all the measurements, take care of engineering, design, and then on to permitting and reaching out to the towns for the approval and the permissions to build these systems, as well as the utility companies to get an interconnection agreement. All said and done, you know, the installation can be done after permitting, obviously, from maybe 1 to 2 days, depending on the complexity of things. I've seen it been done in as little as 1 for a smaller system. And again, that's on the shorter side. But yeah, after that, a little bit of closing out as well. So we wrap up with the inspections, work with the utility company to install the smart meters or any other equipment that needs to be installed, and then close out that project, providing everyone with a digital binder, in a sense, that has all of your system documents, warranty information, tax information, all of the above there. From there, once we close out with the utility, you'll get that permission to turn on, flip the switch, and you're running on clean energy. And with that, we'll open up for some questions.
Casey, this is Jillian from Natick. Just looking through the chat and thinking about some questions that we received ahead of time. I'm wondering if you could explain, I know through your program, you're offering both lease and purchase options, I believe. Can you explain those? And then another question that came through the chat was around roof age and what guidance you might have for residents on like what the right age of a roof is when it's maybe too old to go solar.
Yeah, absolutely. So touching on the first one as well, there's really two options, right? There is the purchasing outright. The loan option would include purchasing outright. It's kind of along the same lines. And then a PPA, which is a power purchase agreement or a lease agreement. We do have a PPA available through this program. I will say as a whole, we really try to, I want to say shy away, but really kind of urge people in the direction of that ownership model, only because it works out best for the homeowner. In the end, you're reaping all the benefits of the tax incentives, the smart rebates, and all of that as well. Not only that, but adding to the value of your home as well. So again, the really key difference there, I would say, from what the experience is like. Ownership, the system is really designed to offset your entire usage. So if you're making that purchase, then you can expect no electric bill. In the case of a PPA or a lease, that's something where you're really only getting a discount on the electricity, essentially. So in exchange for a company installing on your roof and generating that energy and contributing to the grid, you in turn aren't receiving all of the credit for the energy, but in actuality, a discount on the energy that you are receiving. And then, I'm sorry, I rambled so much, I forgot the latter question, but.
On the roof age, and can you also share as part of that how you handle conduit?
Yeah, absolutely. So it's very customized. I'm going to start backwards. So from a conduit perspective, as part of the process, we're putting together an approval page, what we call it anyways, but a kind of preliminary design after we've taken all the final measurements, and really we'll outline there like where conduit would be run or where we would suggest it to be run. In some cases, some of you might have thought ahead of this and kind of run some. I've had a couple conversations already, but long way of saying it is a customized approach. So we'll always kind of give a recommendation and then have that. We need your sign off before we're making any of those decisions. So we'll have that conversation before we make any of that. From the roof question, generally speaking, we tend to ask. I'll put it this way: a system is typically have a lifespan of about 30 years. So with that, if you're looking at replacing a roof after, or I don't want to put a number on it, let's say, but anything under or older than 15 years, we would really take a closer look to see the condition of those shingles and make sure that it's a viable option. In the end, what we're trying to prevent is going down the line, having to replace those shingles or replace anything on the roof, which would require taking off the entire system, having the work done, and then reinstalling the entire system. So just something to consider there.
Thanks, Casey and Colby. We appreciate it. And we know you'll be, there's a lot of great questions in the chat, and we unfortunately can't get to them all right now, but we will answer all of your questions at the end of the night. So stick around if you have questions, or alternatively, go to our website and sign up for the no-cost assessment, and the ACE Solar team can connect with you directly and answer your questions on a personal level. So next we have Joseph Wood from New England Ductless, our air source heat pump installer. So Joe, you can share your screen, please.
Thank you, Julian. Let's see here. All right, share and, whoa, get out of there, buttons. I have navigation up at the top of the screen that's giving me some trouble. Excuse me just a moment. Hopefully I can double click in. How do I move that navigation? Excuse me. Hide, floating, meeting controls, slideshow, and let's go. Thank you. Can everyone see that okay? All right, my name is Joseph Wood. I'm the owner of New England Ductless. We're based in Milton, Massachusetts. I thank you all for having me. I thank the team that's working on this, all the coaches and the participants, and nice presentation as well. ACE Solar. I should say we have solar on our roof. I believe in it and vouch for it. We represent air source heat pumps, and we do Mitsubishi and LG. And if I can get my, oh Lord, excuse me. My keyboard here gave trouble. And I'm on a touch screen. Excuse me, guys. Come on. There we go. Let's hope that didn't. All right, thank you. What we are all about as a company is we practice the golden rule. We make sure that we treat our customers, our vendors, our coworkers all like we want to be treated. And the same goes for your home. We believe that what we're doing and what we're discussing here today is the future. There's no more way that we can continue to burn fuel that is not able to be recovered in any manner and hit climate goals. So we definitely are passionate about that as well. And as part of this program, and even outside of it, we try to provide, because of our specialization, market-leading installations at a great price. You can count on us for great workmanship, living through our value system and bringing great technology to your home. As far as myself, I am a plumber by trade. I have done many heating systems, boilers, furnaces, and was attending Mitsubishi conferences for many years as they tell you about what's going to happen in the future, and the future is now. We've gone ductless only, and it's been a great thing for us and for our customers. If you're calling into us and booking a appointment, you're likely to speak to Fariba. Normally, you would also speak to Emily. She just had a baby and is out on maternity, but Fariba is a great person to have on the team. And if you get a chance to speak to her, you'll be happy. Excuse me, I'm falling out of frame here, huh? And our project managers in the field who make site visits are named Brian, Corey, and Arthur. Great team as well. They will basically review your home, discuss pathways for where piping and such may go, and provide you the proposal. A question that we often get about heat pumps, heat pumps, I always say in New England have been traditionally a bad word. They stopped working at around 30 degrees Fahrenheit. The products that we're talking about are a whole new class of product. They provide 100% of heat down to 5 degrees Fahrenheit. There's actually new systems that are coming out that are even lower than that. We don't really need that in our climate, but even as it falls below zero, which, is a question because it happens. What will happen? Well, these units still at the worst performance they do, they'll give you 75% of their capacity. And where we live, we always consider it cold. It's not really that cold though. Our design temperature in New England is about 8 degrees. And when we get below that, it's usually a matter of hours, like from 11 to 4 in the morning, and then the sun begins to come and the temperature stops. So we've got many applications where these are primary heat. Over on my left here, we built an in-law just before COVID, and I'm 40 years old and I live with my mother again, which is great. And we put Mitsubishi as the primary heat source for her place. So definitely they work, and they work great. As far as how our pricing works for this program, on average, you're going to see a 15% discount, but every home is different. And what we need to let you know is you'll always get a firm price, because you may need something with your electrical panel, or you may not. Whatever it may be that you need or you want, we will price individually for you. I have some pricing packages I'll go through in the next few slides. Those represent real world jobs, and each of them had an example of something that added to the cost, because every person who submitted a proposal to be part of this program has to bid against something that's pretty stock. So this, I think, gives an example of some of the things that we see out there. This is a home that we did actually a few years ago in Weymouth, and it was a great house. If you stood on that porch, you'd be looking at the ocean. It's beautiful. Casement windows, the type that crank. You can't put a window unit in it. They also have a oil boiler suspended from the ceiling in the basement, because it takes on seawater and things like that. They wanted air conditioning. You can see the unit in the interior photo. It's up in the top right of that image. That's an example of a wall-mounted unit. And that is at the front right corner of the home. And if you look at the image on the right-hand side, you'll see that nice deck. There's a piece of white piping, what we call slim duct, that goes up between those two windows on the second level. We had to run the piping underneath the deck over to that front right corner of the home. So this had some things that brought it up above average. And this little case study here, we'll talk about that. We had new piping, or not new, I'm sorry, more piping than usual, more wiring. We had to modify the panel a little bit for the electrical needs, some extra time. They also chose a 3-zone system, but only put 2 zones in it this time, so have a bit of room to grow. And they added the Wi-Fi control. So you can see there's about a $1,200 increase in this job. We look at this job here in Milton, great house, also, beautiful home, brick exterior. If you look at the image on the left-hand side, you can see we have a Mitsubishi Hyperheat product hanging on the wall on the driveway side. And if you look behind it, you'll see a brown conduit, which does really nice on the brick. If you can look up to the 3rd floor, I'm a little bit colorblind, but I think that house is blue on the 3rd floor. You'll see there's some more up there. We had to use a cherry picker to get the piping up there safely because it was too tall for laddering. So same thing. And this is a home that any other form of renovation would have been so invasive. It just wouldn't have been best for them. So we had brick penetrations. We sometimes do that if it's a ground level ourselves. Other times we may get it cored professionally. We had a bit of demolition work, panel work in the electrical, that boom truck or cherry picker, as I called it. Also the system, which we actually did about 4 years ago, they just finished an addition, and that future zoning that we had added to it is now, taken up. This was about $7,200 above what is a base price in this system. And here we have, I always like to show the photo. People wonder how we get the pipes from A to B, and that picture of the cat is, we're drilling through the wall here to run. It's a 2.5 to 3 inch diameter hole. You never know where you're going to get on the other side, or we do know where we're going to get, but we didn't know the cat's going to walk up. And there we have a cat looking at us, but it's not a lot to get the units hung. You see in the center image a master bedroom. Further down that hallway is it's like an open bath, and you can see a wall mount unit hanging right there. And if you look at the image on the right hand side, I think we had to pull a shrub, and you can see some white conduit. This family was just about to have, I think they were having a baby at the time that we put it in. They had started off with the 5-zone system with 4 indoors and decided, because they were really happy with the way it was going, to do the 5th at that time. So some things here. At this period in time, there was not what we call a branch box enclosure built and sold by Mitsubishi. There is now, but we had the removal of a shrub. We had a landscaper do that, some extra pipe time. The inspector required indoor switches at the indoor units to shut them off, which is not a common thing. And we brought in a professional cleaning, knowing they were going to bring home a new baby. So about $2,300 above a base price. But you know, our name is New England Ductless, but if you peruse the LG or Mitsubishi or Fujitsu, any of these websites, you're going to see there are ducted components, and we offer those. We also offer train heat pumps through this program. So if you have a home where you have ductwork or you're not too keen on some of the things we've shown here, there is no other product on the market that has the versatility of the ductless product, and it's a great solution. We're happy to be here working with you guys. Our pricing is very competitive, and we are standing by ready to help you guys out with anything you might need for your home. And I think this is our contact information. 781-995-2665 is also 995-COOL. And the Metrowest Clean Energy site is the best place to sign up, and we'd love you to check out our site too. We just got our Metrowest lander page up, I think yesterday, so today it might have been. So just in time. Thank you. And if you have any questions, I'm happy to help.
Yeah, thanks, Joe. That was a great presentation. Let's get to a couple of the questions. So we got a couple folks that want a quick rundown on some of the basics of how they work, specifically the difference between ductless versus ducted, and also just the terminology of mini splits.
Yeah, so a regular system that you might call central air has some form of a box, usually in an attic or a basement. It's got a whole duct system that travels. If it was in the basement, the ductwork would probably be in the floor. If it was in the attic, it would probably be in the ceiling. Those are what most people would call a split, versus if you think of a window unit, it's not split at all. The compressor and evaporator are together in one. You just put it in the window. A mini split is, originally that name was, from a unit on the wall, a unit outside. So there is an outdoor component, of course, because the system is split. But the term mini splits is almost being phased out from the standpoint of it's no longer just that unit on the wall. And it's changing so rapidly, but just maybe 5 to 10 years ago, about 85% of the units that were sold were of the wall mount variety, the type that are high on the wall near the ceiling. We have, like I was talking about my mother's in-law, we have 2 ceiling cassettes. They're flush mount with the ceiling. I think Mitsubishi calls them the Easy Fit in their consumer literature. There are compact duct units. You think about a ranch home, and Framingham's got a lot of campanellis. You might do 1 wall mount, for example, in a large open space, and then the 3 bedrooms, maybe do 1 compact duct above it that drops through the ceiling. So there's a lot of different styles of equipment out there. Hopefully that answered that question, Frank.
Okay, perfect. Yeah, and then I think it could be helpful too if you just go through a quick overview of how they heat and cool a space with basically pumping hot air into the house and then pumping out pumping in the cold air.
Sure. So refrigerant is the magic that makes it all work, and refrigerant exists. I always go back to a window unit because I think we all kind of have used one, hopefully, and we're drawing the warm air from the room across a coil that's full of refrigerant. The refrigerant basically absorbs that heat, and then it just discharges outside. You could say it pumps it, because a heat pump is literally reversing that, and it draws heat from the outdoors and pushes it in. And back to that, so the refrigerant, it's not producing heat. Like, a common question is, aren't these things electric? Don't they use electricity? Yes, they have power to them, but they're not like if you turn on your toaster and you see the coils glowing. That's what we call resistance heat. It's the same as baseboard heat. It's considered 100% efficient because if you use your toaster to heat your space, it's not, there's no exhaust pipe. You're not losing anything, but it's also not an efficient way to heat, though you're getting every kilowatt came out of it. Unlike a gas boiler might be 85% efficient. You burn fuel, 15% goes through the exhaust pipe, 85% into your home. With the technology that Achieve offers and the technology that we offer, we're not producing any, we're producing energy, we're recycling it from another source. And we may think it's cold outside when it's 0 out, but you think about water freezes at 32 and it boils at 212. Well, refrigerant boils at like hundreds of degrees, and I don't think you could freeze it on planet Earth. So it's only in relation to that refrigerant. So though it's cold to us as human beings, it's still got quite a bit of warmth. And what a heat pump will do is absorb that heat into the refrigerant and pump it back into your home. And the ratio that you're looking at, I use the analogy of a toaster, 1-to-1, kind of 1 unit of energy, 1 unit of heat came out. We're looking to get somewhere at the very worst it would ever be, like when it's down at, -5, you're still around like a 2 ratio, but you might go at some parts of the season up to 5. And the majority of our season here in New England is shoulder season, 40-degree weather, 50-degree weather, things like that. So they work great. They're very efficient. And yeah.
Okay, great. Thanks. No, that makes sense. And we have a question about swapping out systems from a traditional installation or switching from gas or oil heat to a ducted, which is a ducted heating system, to an air source heat pump. So if you go over quickly some of what would be involved, that would be great.
Yeah, so we replace systems often. Every time you do it, there's a sizing calculation called a manual J. It basically looks at your home like a shoebox. It models how much heat it would gain in a certain environment and how much it will lose in a certain environment. Your heating or cooling system is just there to counteract that. So we size your home first. We discuss the options that you might want or need. We provide those options to you. Usually, I think every job's going to get a few. It's not really for us to say what should be in your home. We give advice and guide you through, but we want to make sure that we're not telling you, you only have one choice. And we, after getting the green light, we work with Mass Save for financing if people choose. We do in-house financing. We offer the rebates. We register all the warranties. And we will complete our installation in nearly all cases. If you're removing your other system, we'll work to handle that for you, be it an oil tank or abandoning gas, things like that.
Great, that sounds good. And then one last question. So for people that already have solar on their houses, if you could talk about some of the benefits of adding heat pumps on, that would be great.
Yeah, I think that a solar is probably better equipped to handle the question in some regards, because I believe that my understanding of solar design is they don't necessarily try to turn it into a money-making machine for you. They're really just trying to give your home the best it can, but not give you like 200% of what you need, but maybe like 110. So, but heat pumps, they work well on any form of electricity, but particularly energy that came at a low cost or no cost from the sun. So the heat pump will not know where it's getting its energy from. But if you're in a position where your home produces excess, it's really, a no-brainer. And it's something that, you may cover it all, you may cover a portion, but it's house money at that point, in my opinion.
Perfect. All right. Thanks, Joe. Well, we're going to have a bigger Q&A after Larry Wessard from Achieve Renewable Energy talks about ground source heat pumps. So thanks, Joe. And let's welcome in Larry Wessard from Achieve Renewable Energy.
Thank you, Frank. Just give me a moment to share my screen. Okay. I am going to introduce you to ground source heat pumps, which have some similarities to the air source heat pumps and some differences. And we are, as the other installers, we're very grateful to have been selected for the Metrowest Solar and Clean Heat Challenge, and are looking forward to helping residents in all 4 communities. Today, I'm going to explain what geothermal or ground source heat pump HVAC is, talk a little bit about the benefits, a little time explaining how does it work, an introduction to what the components look like, and then some summary information on project pricing and operation, and then a brief Q&A before the general Q&A starts. Ground source heat pump systems are typically whole house heating and cooling solutions. We're much less likely to address just part of a house than New England Ductless would be with their equipment. And the heating and or cooling is distributed a variety of different ways, most commonly through ducting, but that isn't necessarily the only choice. Radiant flooring is also very compatible with ground source heat pumps. And we have ductless ground source heat pumps, so we have similar wall mount, console mount, and ceiling mount devices similar to what Joe described a few minutes ago. Baseboard is possible under certain circumstances, but doesn't provide air conditioning. And if you're working on off radiators, especially steam radiators, that's unlikely to be compatible with the ground source installation. So the first thing you need to know about ground source is that there's no volcano needed. The type of use of geothermal energy you see being done in Iceland and on Discovery Channel or wherever you might see a show about it is direct use geothermal, where the groundwater is so hot that it can be used directly, or there's actually steam that can be accessed through drilling. What we do is a geo-exchange, where we're moving heat from the moderate temperature earth into the house during the heating season, and from the house into the ground during the cooling season. So no volcano. The system works this way. On the left, we have a diagram showing the heating cycle, where in the vertical closed loop that's depicted here, we're cycling antifreeze through the ground. It's coming up out of the ground warm. Heat's extracted from it, put into the house, and then that returns colder. And as it travels down and exchanges with the bedrock, rewarms, and then the cycle repeats. In the cooling season, we're taking heat from inside the house and injecting that into the ground through the closed loop system, and then using cold or cooler antifreeze coming back from the ground after the exchange happens. And again, the cycle repeats. This slide shows some of the general benefits of ground source heat pump systems. They're very comfortable. They provide a very even heating and cooling. The operational cost is much lower than fossil fuel options. They're very reliable. They have a long service life because they aren't exposed to the outside elements or have wear and tear from having combustion of fossil fuels. That the efficiency of the systems can dramatically reduce your carbon dioxide or other greenhouse gas emissions, and eliminating the use of fossil fuels in that combustion removes the threat of carbon monoxide poisoning from, at least from the heating and cooling source. The systems are also very quiet, and all of that can provide peace of mind. Trying to build on what Joe explained as far as the operation of the air source heat pumps, the ground source heat pumps move or extract heat from the ground during the heating season. So 1 unit of electricity is used to operate the equipment, and that isn't used to make the heat, it's used to move the heat. So it can harvest 4 units of free energy from the earth to be delivered to the house. The way heat pumps work, the waste heat from running the equipment always dumps to the hot side. So that helps you in the heating season and holds you back just slightly during the cooling season, though ground source heat pumps are incredibly efficient at cooling as well. Thinking about how systems work, if you have Joe's toaster example or an electric hot water heater, and you put a kilowatt of power into that, you're going to get a kilowatt of thermal energy. Heating equipment is rated on a coefficient of performance, and it's a ratio of what do you get out versus what did you put in? In this case, you get out exactly what you put in, so you end up with a COP of 1. With a fossil fuel system, no matter what you do, some of the heat is lost up the flue with the combustion gases. So if you have a 78% efficient fuel oil system, which might be, 1970s, early 1980s vintage, you only get 78% of the heat and you lose the other 22% up the flue. It's sort of the opposite situation with a ground source heat pump, where you're paying for the operation of the equipment, but then it's harvesting the heat from the ground, and then you get to use the entire pie to heat your home. Relative to operation costs, ground source heat pumps are the lowest operational costs. Most expensive way to heat in our areas with propane, followed closely by oil. Older air source heat pumps that aren't as efficient as Joe's are sort of in the middle. Natural gas, because the fuel is so cheap, is lower, but the ground source is lower still in operating cost. And these dollar values are how many dollars it takes to create 1 million BTUs of heat. Your typical homes in Massachusetts use tens to over 100 million BTUs a year for heating. Greenhouse gas emissions are lowest with ground source heat pump and even lower than natural gas, quite a bit lower than propane and fuel oil. Electric resistance is about the worst way to go if you're trying to keep your greenhouse gas emissions low. Now, these are with grid tied electricity. If you either buy renewable energy through a contract or you have solar panels, the ground source heat pump carbon emissions can go as low as 0, and that's also true for air source heat pumps. There are a variety of benefits to the equipment, it being a friendly renewable energy source, really super high efficiencies available for both heating and cooling. And that can result in very high savings on operational cost and reduced carbon footprint. The equipment also is installed without PVC or ozone depleting refrigerants and all of that. So that's all beneficial. Now, as far as how the equipment looks, form follows function. So in the center here, we have 4 ducted ground source heat pump units of various model lines. And they look like a residential furnace. The geothermal magic happens down in this bottom section, and then there's an air handler that's packaged into the same box. These can be split apart, or you can buy a configuration where they're split apart. Here's one of the geothermal split units. And then the air handler can be remote. And we have units that make hot water that can be used for domestic hot water, radiant flooring, or potentially, under the right circumstances, baseboards. And those have the general form of a boiler. The underground components there are a variety of different options available. The 2 on the left are more popular in areas where there are bigger lot sizes and the regulations are different for how to use a pond than they are in Massachusetts. The 2 on the right are the most common installations that we have, either a vertical closed loop, which is the most common installation, maybe 70% of installations, or a groundwater-based system using a well in the bottom right. The horizontal loops in the upper left are possible in Massachusetts, but digging here is expensive and lot sizes are small, so they make up 10% or less of the installations. As with the other contractors, we have special pricing for the Metrowest Challenge. We were selected via competitive bidding, and we bid special configurations that were presented to be representative of installations at typical homes. And we have different model lines of equipment to meet the different sizes of the homes and to provide different options. There are price modifiers that allow changes in that base system price based on extra features people might want, or sometimes reductions in cost based on size of a home or something of that nature. And all this information is publicly accessible. Most of our projects do use modifiers for the cost. There are lots of people want multiple heating and cooling zones for their house. They want internet connectivity of the equipment, or they may just have a bigger home and need to add additional capacity. And all that can be handled in a very transparent way with the pricing that we've provided. Ground source heat pump installations are more expensive than an air source heat pump installation typically, especially in the case where we're dealing with a whole house solution, and you might be comparing to an air source solution that is for only part of the home. But there are very good financial incentives that make our installations cost competitive. There's a 26% federal tax credit this year that should be in place next year as well. MassSave recently activated a $2,000 per ton of capacity rebate that has a cap of $15,000, so that tracks up or down based on your house size. To be eligible for that, you have to have an account with one of the participating utilities, which most people in the community, the 4 communities, will. And then you also have to currently be heating with fuel oil or propane for that incentive. The Mass Department of Environmental Resources has an alternative energy credit program that was more lucrative in the past, currently provides something between $800 and $2,000 for typical size homes. And then Massachusetts exempts ground source heat pumps from sales tax. So at Achieve, every day is tax-free weekend. There are also financing options. MassSave has their heat loan, which provides 0% interest over a 7-year term with a $25,000 cap for a single family or a $50,000 cap for a 2 to 4 residential unit building. We also have industry provided financing that is applicable to our projects. And one example is here, same as cash option. There are other choices available, but at varying interest rates and varying requirements for approval. Now remember, we don't approve your loans and we don't take in your private information. That's all direct with the lender that's helping with the heat loan, or with EnerBank providing the industry sponsored financing. So we'll help you be in contact with them, but your approval will be direct from the lender itself. And with that, I'm finished with the presentation. A couple of minutes till 8, so it looks like we're pretty much on time. And if there are any brief questions, I'd be happy to take them.
Great, Larry. Thanks so much there. As somebody who's not a big fan of waste, the efficiency of this particular technology is really fascinating. A question just came in, and it ties in with another question we had from earlier. Is ground source possible if the home is on a concrete slab? And what about the ability to drill through ledge?
Okay, let me handle those in reverse order because the drilling through ledge thing is my favorite question because the answer is kind of counterintuitive. The drilling rigs we use are the same ones that put in water supply wells, and they're designed to drill through bedrock. And they will drill very quickly through bedrock. The process is actually slower and more expensive going through soil because they have to set a steel casing, and especially now with tariffs and environmental conditions, steel prices are very high. So drilling through soil is almost twice as expensive as going through rock. No problem drilling through ledge. The only issue that we run into with shallow bedrock is if it's so shallow that we can't get the pipes into the house. So it's nice if we hit bedrock something like 5 feet below the surface or more. And that gives us plenty of room for excavation and piping. Now, the slab construction is not a barrier. We can still bring piping into the house. We've done other projects at slab on grade homes. In fact, I was speaking with someone from one of the communities that has a slab on grade construction this afternoon. So that's not a barrier at all.
Sticking to the outside theme, can systems be installed when you have a high water table?
Yes, that's not typically a barrier. The fact that there's a high water table in the soil is kind of counteracted by that steel casing I mentioned that's advanced to keep the hole from collapsing. That essentially isolates the hole from that water. If we hit substantial water at greater depth, once we're in bedrock, sometimes that can require special measures to control it. But shallow water is usually not an issue. I mean, every project's different, so we'd have to look at the site-specific conditions, but we've been through that many times.
Right, just one last quick wrap up, and then we'll turn it back to Sean. What outside equipment will someone have with a ground source heat pump installation?
None. The vertical closed loop borings, if we use that type of installation, are all finished below grade. So in the photo that's still up on the screen, there could be vertical closed loop under this lawn and you wouldn't know it. And then there's no outside condenser or any of that for a ground source system. If we put in a groundwater based system, then you will see the wellhead, which will look exactly like a residential water supply wellhead. And they're not too intrusive, and they also make fake rocks to cover those up with.
Well, great. Thanks, Larry. Like with the other installers, we're very pleased to have Achieve Renewable Energy as our ground source heat pump vendor. And I'll turn it over back to Sean.
Thank you, Matt. I'm just going to share my screen again. And I apologize if you can hear a cricket in the background. It's making me feel a little self-conscious that my part of the presentation is going to be boring. Yeah, so thank you all presenters for that excellent look into the technologies and the offers. Just going to move right along, as I know we're past 8 o'clock. We do have some time for an extended Q&A for those of you that are able to stick around, and we'll have some additional information towards the end of the presentation. But what I'd like to do is open it up if you'd like to ask an additional question. We're going to go through the chat and kind of pull some questions from there. But if you also want to speak, if you can raise your virtual Zoom hand, if you can see that. I'll be checking the participants list. So you have 2 options. You can message in the chat or just raise your hand and we can try to get you and see if we can answer your question. So I'm going to open it up here and let me see if I can change views so that way we can see everybody. So we're going to go into gallery view and I will stop my share for a second. Hey everyone. So yeah, we can, if anyone has any questions, feel free to jump in and I'm sure we can tackle them as a team.
Oh, Larry, I think this is a pretty good question. I know you were just speaking, but someone wanted to know the difference between open and closed systems, and do you use them and why?
Sure. Yeah, a closed loop system has the geothermal borings that I described, and that has heat exchange piping in each boring that goes down to the bottom, turns around, comes back up. And that's called closed loop because there's a continuous circuit of piping, and the fluids we circulate don't interact with the groundwater at all. They stay in the pipe. A An open loop system would use something akin to an irrigation or private water supply well. And in fact, both of those can be set up for dual use with geothermal, pending local permitting. And in that case, groundwater is pumped from the well through the heat pumps where the heat exchange happens, and then it's discharged back to the well. With the closed loop system, the water quality is a known factor because we're putting all that into the system directly. With a groundwater or open or well-based system, then water quality can be variable from place to place and can be a factor as far as maintenance goes.
Thanks, Larry. I see a question from Dick and Jill Miller about if these are the only vendors available through the program. And I did just want to answer that on behalf of the municipal staff. So yes, Ace Solar, New England Ductless, and Achieve Renewable Energy are the three installers that were competitively selected through this program. There are other installers out there who are providing similar services, and we encourage residents to check out Mass Clean Energy Center to learn more, but these are the vendors that in our communities are offering the discount and pricing and are working directly with the municipalities. We also had a couple of questions around the air source heat pumps that I wanted to ask Joe about. Joe, one question that was asked was by Roger Luckman, and he was asking for air source heat pumps, how often do you recommend keeping an oil or gas system as a backup?
I saw that question pop up, and it's a good one. I think a lot of our clients have an interest in removing all fossil fuel from the home. Our very first project was doing a primary heat source, so it's not that we don't have the experience in doing so or the confidence in going all air source. I always think, however, if you already have a system installed and it already works, it's not at risk of carbon monoxide or it's going to leak oil or something like that. It doesn't cost you, generally speaking, anything to keep it. Anytime that you ever remove something, the cost is exponentially smaller than the cost to put it back in. Removing an oil tank, $600, say, putting one back in, $3,500. So I always ask people just to take a moment, if they're not sure, because there's no cost to keep it. And but as far as recommending it, I don't, do it for any other reason other than, having two systems is good. You see people up in the North Country with a Potbelly stove in addition to whatever else they're using, and it doesn't hurt to have two things. I have a window unit at my house just on standby, and I have a space heater too.
Awesome. Thanks, Joe. We have a question from someone who wishes to talk, so I'm just going to allow you to talk, Donna. Feel free to unmute yourself, and if you'd like, you can ask your question. Hello? Looks like we might be having some issues. I'm going to ask you to unmute, and let's see if that fixes things. Donna? Well, we'll come back to that. Donna, if you could post your question in the chat, that would be great, and we'll make sure also I'd like to say any questions that we're not able to get to tonight, we will make sure to follow up via email and reach out to you directly. So I'll just add that. If anyone has any other questions they'd like to throw in, feel free.
Okay, I have an Ace Solar question. So JM said, following up, what percentage of residential customers are able to sell excess energy they generate? Is that even a thing that happens in the Northeast for this area?
Yeah, excuse me, for sure. And actually, I'll probably touch on another question that they asked as well. But yeah, I'd say tough to put a percentage on it, but I'd say more than half, probably. Really, we're trying to, when we're designing the system, we're looking to offset, your entire electric usage, and that's, can change from year to year, from month to month. So We always try to build in a little bit of an overage. So, if we're modeling for that and on a given month you're using less than you have, historically than what we plan for, that you'll be compensated in the form of net metering. And what that is basically when the utility company sees that, you've generated more than you've used on a given month, they sort of return the favor in the form of credits on your electric bill, which then you'd use over time. I will say, given that we are in New England, there's a kind of peak and valley to how much sun access we have. So typically everybody's generating less during the winter than you are during the summer. And we're taking that into consideration as well as part of that annual assumption, right? So might be generating a little bit more and kind of storing up some of those credits during the summer. And then when it comes time to the winter where you're not able to generate as much, might be dipping into that a bit. So more of an annual kind of offset, just to give you an idea there.
Okay, great. Thanks.
Just a follow up, I think I think it was touched upon in each presentation a little bit, but if each installer could elaborate on, just giving people a sense of the operating costs of these systems. I think in the case of solar, it's really not much there. In terms of air source and ground source heat pumps, I'm wondering if you could kind of give people an idea of, the savings that are available compared to some other traditional technologies that people might be familiar with.
Larry, do you want to go first, or would you like me to?
You can go ahead, sir.
All right. I have a Excel file that we use, and it has all the formulas where you can put in your actual current energy costs, whether it be oil or propane or natural gas, put in, a bunch of other parameters and get some good estimates to that. It's a moving target because this year is colder than the last, or warmer, and, people use more heat or less heat. And sometimes a byproduct of more efficient systems is people use them more. And it's something that, is kind of like, keep that thermostat off. We can't afford to be letting all the heat out the window. And then finally you have something that's efficient and used a lot more. So there's a lot of variables that go into it. But I think that Larry's slide he showed earlier that shows a COP kind of rating, and COP, again, like you use a unit of energy and it produces how much heat. That's probably the best way to baseline them all, in my opinion. And he had an additional slide, not to steal your thunder, Larry, but he has the other one that shows kind of where you're at. And, I think you had propane at the top, and then you come down, you come into air source, then natural gas. And that's a place I think, I'll pause there, is our technology versus natural gas. If you're in a modulating condensing gas boiler, that's properly sized, that is, and functioning the way it should, because not all of them give the rated efficiency. Or same if you have a modulating and condensing gas furnace, you'll probably mostly exceed the efficiency of our systems. So I don't think it's a pound for pound flat win on that. There are many other reasons why you might choose to go air source in lieu of those things, but I think that Larry's side was a good representation of it.
And what we generally find is that compared to fuel oil and propane, at least at the pre-pandemic levels, because a lot of the fossil fuels are pretty inexpensive right now, but at pre-pandemic levels, the ground source installation might be 60% or more lower than fuel oil and propane. Natural gas, it does depend on the type of natural gas system, but we can come in at a lower operating cost than natural gas, but not tremendously lower, maybe 20%, 30% at the most.
I wanted to just add something to that, Larry, too, is I think, for anyone out there who's at the inflection point where your system's at 15 or 20 or greater years old, these are great points to consider it. I don't necessarily think, unless, you're committing to clean energy, that you should tear out a 5-year-old system, on the other hand. And that came down to that earlier question about, do you keep a backup? And I'm like, well, I hate to see you throw away something that's perfectly operable. So a couple things there. And then, yeah, I don't think I said it. Larry's correct. The price of fuel oil right now is lower than it has usually been, but traditionally speaking, that's prime time right there for air source heat pumps is to beat those out.
Thank you both. We have a couple questions for Ace Solar. I wanted to flag a question that I saw you answered in the chat directly to one of the participants, which is around if you're interested in a heat pump and solar. In the signups that we've received so far, a lot of residents are interested in all three technologies, or at least learning about the different heat pump technologies as well as solar. How would you recommend they go about staging that kind of assessment process with the installers?
Yeah, absolutely. And I can address that. But I think it's, I would recommend going the heat pump route first, getting an idea of a rough idea of how much that increased energy usage would be. I mean, we have some estimations that we've used. We certainly kind of run that calculation in the past. Just obviously rough, but I would think, and just correctly me if I'm wrong there, but I think with some of those estimates, you might have a rough idea of what that energy usage would be.
I'm sorry, you're asking about what we would expect?
Yeah, no,
Yeah,
like if as part of that, if you're providing some rough idea, or if that's something.
I think if we have an understanding of square footage of home and what current energy bills are, we could probably give you a comparison to that from a pound for pound standpoint. Yes. Great.
All right. Yeah. And then in that case, we can anticipate that and sort of build that into our projections as well.
Great. And on the solar front, sorry, Larry, did you want to add to that?
I was just going to say that it will depend on how energy efficient the home is, your insulation, window quality, things like that, and the size of the home.
Right.
But we do energy estimates as a standard part of our proposals, and for heating and cooling for the year, a lot of homes will fit into the range of maybe 6,000 to 10,000 kilowatt hours a year.
That's helpful to know. Another question that was asked is what variables impact the cost of solar installation?
Yeah, I saw that one as well. So there's really a lot. No, I don't say a lot, but that's why it's a very customized solution, right? The height of the roof, really, the extreme factors, I guess you could say. So pitch of the roof, anything that would kind of add to the difficulty of installation. Pitch, height of the roof, the type of roof as well. There's a little bit of an increased cost for like a flat rubber roof or something non-traditional. Ground mount, certainly there'd be the added cost of sort of trenching to that area where we're installing that ground mount. Then something that the other guys had touched on as well, if there's any upgrades or anything needed as part of like the infrastructure of your home, so maybe a panel upgrade, sub panel install for a battery backup system, things like that. I'd say those are really the biggest, most common factors, but we're sure to kind of detail that or everything that would be a factor there as well.
Good. There's one that came in before. We're hopefully in the far side of the pandemic, but it's still a legitimate concern out there. So if you can share some of your experiences from the last year, that'll help folks feel confident that assessments, installations, et cetera, will be done in a safe way for folks moving forward.
Yeah, absolutely. I mean, I'll jump in. We've kind of shifted pretty nicely, I'll say, during the pandemic. We've kind of taken, I know solar, and I actually saw a question before we jumped in here about another company was kind of going door to door. It's really something that even in my kind of getting into the industry, really saw as kind of invasive. So we really take a very educational and really like not even heavy, I'd say, light on the sales approach, but really like a non-sales approach to this. So not going to be really doing anything like that, but we're really transitioning nicely into virtual assessments. Google Maps is always nice, but we also have other technology we use for satellite imagery, and again can get really dialed in with those measurements. And then as well, any meetings that need to take place, we'll certainly abide by any customer's personal preference. But everything else can be done digitally. Digital signatures for contracts, digital wire payments, things like that. So, whatever makes you feel at ease, we're happy to accommodate.
All right, thanks, Casey. We just got another question. Would you still need to keep an oil system if you switch to heat pump or solar?
I'm sorry, I don't know if that question was directed to us because I heard solar at the end.
Sorry, that could be to Larry, Joe and Larry. Yeah.
Yeah, I'll say before
specifying.
Solar directly wouldn't really contribute into that factor. So I think, yeah, Joe, you guys probably speak to that more.
And I'm sorry, was the question whether or not you need to keep your oil tank?
Yeah, I think it was that. So maybe, Joe, you could just give a quick description on different options for, supplemental, or if you just want to completely switch.
Absolutely. Yeah, so the product line for air source heat pumps includes wall mount units, floor mount, full central air, what you might consider a central air unit, like a ducted air handler that goes somewhere, closet, basement, attic. They're capable of being your sole source of heat and, of course, cooling. And with them, you do not need any other method of heat. If you already have another form of heat, I mentioned earlier, Campanelli homes in Framingham, they get some of those. I don't know if anyone on here has the oil boiler with a domestic hot water tank living underneath the countertop in the kitchen, which is a common thing from the legacy of the Campanelli home. It can be gone. It doesn't need to be there any longer. We engineer and size and design the systems to be this sole source. And that question about whether or not you remove your old system is something we have pretty frankly with you. And we talk about the pros and cons and help you make the decision that is best for you.
Okay, great. Thanks, Joe.
And for us, our goal is usually to remove the fossil fuel system and replace it with the geothermal system. People are free to keep that system if they want, but it's our goal to make it obsolete and unnecessary. Great.
Thanks, Larry.
Awesome. Thank you. We're going to give the voice chat another shot and see if this works. So we have a question from Lino. I apologize if I'm mispronouncing your name. I'm going to allow you to talk now. And feel free to ask your question.
Can you hear me okay?
Yeah, we can.
Okay, great. First of all, thank you for this forum tonight. It's really important. And my really question is that there's a lot of us by the way, I'm the CEO of Jewish Family Service in Metrowest here in Framingham. And a lot of us in the nonprofit sector want to be leaders in climate, in preventing major climate change. So I think one of my major questions is for all of us is really the cost benefit of the different technologies. And also I put this question in the chat was, how do you define small business, right? Because we're all in the nonprofits. Some of us range from a $3 million budget to a $100 million budget. So how do you define small business? And for us, because we have boards of directors, it's really, they're going to ask, give us the analysis of cost benefit for our organization. If you can comment on that, I really appreciate it. And thank you, because we're all very committed to this, and we're excited. So know that we're behind this major effort. Thank you.
Awesome. Thank you so much for your question. I will bring that to the team. Definitely a great question. I think I would say just on the small business front, it's not something we've gotten too much into detail on. Just kind of my initial thoughts on it. We look at it, or at least, I look at it similar to the Mass Save program and how they define small businesses. We can definitely work with you to look at that further. I think, we can definitely talk with the different installers in the program, but I think, we're always looking for ways to help, members of our community. So even if it may not fall specifically within the program, there may be opportunities to still, look at facilities. Regarding the savings from these projects and kind of comparing them, I think each of the installers can really get into detail about, how they can show you you know, what your projected savings would be. I'll let you each get into a little bit of detail, maybe how you present that to the customer. But you know, each of these technologies, I think, you know, there's a great case for them to present savings for your home or your business. So I'll leave it there and let the installers, the experts talk.
Yeah, I'll jump in. I had my finger on the trigger there. Yeah, I think from a nonprofit standpoint, I guess I want to step back and say like that line of like small business, really, we're not defining one way or the other, right? I think the biggest thing from a solar perspective ties to the incentives and the level of, or the length of those incentives, I'll say. So the SMART program, I saw someone else asking about this as well. Basically, it's replacing the old SREC program. And it's a per kilowatt hour incentive. So they figure out, let's say 10 cents per kilowatt hour every month for 10 years. For a residential system, you'd get a check or a direct deposit for that amount. If it's 25 kilowatts or bigger of a system, that would qualify for the, I guess, commercial size, and then it would be a 20-year program. So that's kind of a big difference there. And then for nonprofits, really, I mean, that's, I know I talked about PPAs and leases a little bit earlier. And while it doesn't always work out to be a good deal or the greatest sort of benefit from a residential perspective, it is great from that nonprofit perspective where, you know, you might not be able to take advantage of those tax incentives. So in that case, you know, you're just getting the benefit of the energy, some form of discount, you know, for allowing us to build on that house. And then from a public relations standpoint, it's always a good look to have solar up on the roof, right?
I was going to say, Larry, I hope you don't mind me jumping in. The small business topic for us is also a little bit different, but we don't really define it to the tune of what the SBA does or anything like that. For us, small businesses, people that can use our product. And there's a place where our product belongs, and then there's a place where you should be looking at another product. And, you know, so the residential small business sector, and I'm thinking about churches that we've done, you know, break rooms, restaurants, and, you know, many offices and things like that. It belongs there. There's a point where, you know, they always use that word ton, and a ton is referring to an old, you know, 2,000-pound block of ice when air conditioning first came to be. How much air conditioning could that provide when they were blowing air across it? So the residential sector is really 5 tons and below. Our license is 10 tons and under. Once you get above that point, the product, it is quite similar. In fact, Mitsubishi, LG, all the brands make something for it, but it goes into another product that you would call VRF. And VRF is, you know, they can gang them together and do entire hospitals with them, but that's not what we would be doing as a company. It's just not our primary skill set. But we're happy to help any small business. There are incentives out there. They match, and I didn't really speak about that. I know a couple of questions came up, but there are rebates and additional incentives if you're offsetting certain fossil, you know, resistance heat and oil particularly, but there are rebates as well for gas, and those exist in the residential and business markets. Thank you.
Our commercial scale projects you have used equipment similar to what I used in my presentation, and we've heated and cooled buildings up to about 150,000 square feet with that type of equipment. Joe's right, there are bigger machines available, and there you do reach a threshold where licensure changes. As far as nonprofits, we've done installation at houses of worship. We have a synagogue in Malden that we're very proud of how things came out. So when we talk about a commercial installation, that's really anything from a small commercial space, perhaps like a dentist's office, up to what you might consider a much larger retail or storage or even factory type space.
Awesome.
I just want to add, from Natick's perspective, we have seen a lot of nonprofits in our community go solar. We have a VFW that has solar panels, AMVET's building that has solar panels, as well as Temple Israel in Natick has solar panels. and I believe the Common Street Spiritual Center recently installed solar panels. So it's definitely an option for organizations. And I think almost all of those organizations have signed power purchase agreements in doing that. And I believe that's kind of similar to the reason most municipalities sign power purchase agreements, which is because we are not able to take advantage of the investment tax credit that was referenced as an incentive. So it's nice for us because we don't have to pay those upfront costs and go to town meeting or whatever our form of government is to ask for those dollars. Instead, we get the benefit of having that reduced electricity rate, which saves us dollars and ultimately our residents tax money. We did have a specific question about air source heat pumps. It's kind of in the weeds, but there's a question about for air source, does a unit go in each room of the house? Is it one per bedroom, or how does it work when you're thinking about zoning and things like that?
Yeah, it's a good question. And I think the website, MitsubishiComfort.com, is, of all the brands out there, I think they have the most forward website where it's really built for the consumer and you can get a good look at things. They have the ability to have single zone systems all the way up to 8 zone systems. And you could have 8 units on the wall or the floor or the ceiling. You could have 1 or 2. You could build a system with 3 and then add more in years to come. But that's a question. I think it's an on-site question because if we're looking at your home, you may want, say, 2 kids are off to college and 1 still home. Maybe there's a reason to have 3 because you don't use 2 of the rooms all the time and they remain off. Or maybe there's a application where we do what we call a compact duct unit, and it would have, say, all 3 of those bedrooms on one small system with its own thermostat. So there's many ways to do it, but it can be on one on every wall, and it could be something different as well. It's very versatile.
Awesome. Well, thank you, everyone. I think, now that we're at 8:32 now, we just have a couple of just quick announcements / updates that I'd like to share before closing out. If we didn't get to your question, please send us an email. I'll have some contact information towards the end. We will do our best to go through chat. I know we've gone through a lot today, so we want to make sure we're not missing any as we try to respond to those questions. So let me just share my screen again. Awesome. And yeah, so thank you everyone for attending. We encourage you to visit the website. Everything's there, contact information, events, and also, of course, the orange sign up button you can see on the top right, metrowestcleanenergy.com. As we mentioned, it would be great, if you're interested, to check out the events list, see what's there. There might be an event, right in your neighborhood. And so there's a lot of great ways to learn about this technology and also to see it in action. And then additionally, just want to remind you that we're always looking for help for this program. It really is a community-led initiative. So if you're interested in volunteering, you can do so using the link below, which is bit.ly/MetroWestVolunteer. And you can also volunteer or indicate your preference to volunteer on the website. There's also a section there for that as well. There's all sorts of opportunities, things like serving as a coach, if you're interested in tabling an event or two, or even if you want to support the program and have something like a lawn sign on your yard. Things like that are, really helpful. We want to see this be, a community built program. And finally, here's our contact information once again. So in addition to the contact email that's available on the Metro West Clean Energy website, feel free to reach out to any of us, any of the municipal leads in Ashland, Framingham, Holliston, and Natick. Would be happy to take your questions and talk with you more about these different technologies in the program. So once again, for those of you that have soldiered on to this late hour of 8:34, I just want to thank you again for your support, and we look forward to exploring, how we can support you with this program. So yeah, thank you again. Have a great night, and that's the end of the presentation for tonight. Thanks.